Hi, welcome to COMP501 Foundation of Programming. In this lecture, I will talk about nested dictionary. Um, Dictionary like list, you can have a nested uh, dictionary, like a nested list. In a nested dictionary, that means it's a dictionary within a dictionary. And in this case, the dictionary value is a dictionary. Like in this example, I have a student dictionary where student suppose say, which is the key, the value is a dictionary. The dictionary has the grade and the student ID. I also have an outline, student sub outline, the grade and the student ID. And then I can get their information. And just like list, nested list, you will need a double subscript. Student suppose say will give you the value like this. And students are say subgrade because grade is a dictionary within that. You can get the grade, and students are say sub student ID. You get the student ID, and we can see that in the Python program in STEM. I'm not in the right directory, so Python nested 1.py. You can see Jose, the grade, and um, the ID, and Alan, the grade and the ID, using the double subscript. The first subscript refers to the value, and the second subscript would refer to the key within the inner dictionary. So nested dictionary, we can use a lot of like this as what we call like a data structure. As you learn more about programming, you want to learn about how to create your data structure that best match the problem you're working on. And a lot of time, the nested dictionary seem to be a good way to organize the data into logical and coherent fashion. And the list and dictionary are already form a data structure. String, list, dictionary, tuple, set, they are all data structure that you can use in the program that depend on the problem you try to solve. You can create a program that best match the problem set. This is another program. This program I have a grade, and grade is have a dictionary. So the name and what the value is a dictionary. Name, the value is a dictionary, and the dictionary value has homeworks, midterm, and final. Have a list of the homework, midterm, and the final grade. And I could and as user enter the student name, and it will show the student information. It will show the student information if it's in the grade. So let's see how this works in the STEM. This is a pretty big program here. This is just a dictionary for the grade, and if I ever use the student name, if user input in grade, meaning if the student name is in the grades dictionary, then I will get the homework, midterm, and grade, and I will print the homework info, print the midterm, and compute their grade based on these factors here. So if I run this, storing grade, student, let me look at one of the students. Let's see, Ricky Bobby. So this is his information. I guess he did not did so well. So his average is actually below 60%. Let's do another one. John Ponting. John looked like he did the best. and his average is 82%. His homework, you can see the homework value, his midterm and final, and using this formula to calculate his final grade. And what about if I enter something, John Doe? Well, John Doe is not in the list in the dictionary, so you just keep prompting for user the student name again. And I can type in exit to exit the program. Alright, how do you get the song how do you get the list of the song in the Wall album? So in this music dictionary, I have Pink Floyd, and Pink Floyd have two albums, The Dark Side of the Moon and The Wall. So how do I get all the song in the Wall album? I want to get all this song here. How do I get that? Well, music is a dictionary, and the Wall is one of the key, and song is another key in the dictionary. So in this music here, I can get the music in Pink Floyd, and Pink Floyd has The Wall, the album, and from The Wall, the song is the key, so I can get the list. So if I run down Python music, so The Wall have another Break in the Wall, Mother, and Hey You, these song here from 1979. Alright, let's do another example. Write a program that finds the statistics about the student grades dictionary shown below. Print the name and grade percentage of the student with the highest total number of points. Find the average score of each assignment, and find and apply the curve to each student total score such that the best student has 100% of the total point. So I have 5 students. These are their test score, maybe homework or test, but these are their score. And I want to do these 3 information here. This is a big program, so I'm not going to write right now. I just go over the program together with you. And this is a program that I wrote. This problem is one of the challenge problem in the book. So this is the student dictionary. This student dictionary where the value is a list. So I want to print all of the name and the grade percentage of the student. So whenever you see something like this, finding the higher point, you want to have, like the pattern we talked about before, let's have a highest and none. I will create another dictionary called student average, which I'll use it later, for student and grade in student grade item. So I want to get the student name and their grade, and I want to find the average, which is sum of the grade divided by how many grade. So this will give you every student. This is sum of the grade here divided by how many for each student. And then I have a condition here. If highest is none or average is greater than highest, so I have a new highest, and I also keep track of the highest student. And after that, I can print out student with the highest average is the highest student, and his or her average is with the 1 to the 1 decimal, his average here with the highest. So this is how I found the student with the highest average based on their grade here. So for every student, I get their grade, and then I find the average for their grade, and I also store that into student average dictionary. This I'm going to use that later. Next, I want to find out the average score for each assignment. I assume this means I want to find the average score of like 56, 88, assignment 1, 95, 76, 99. I want to find out the assignment like this. And in this case, in this case, I want to find out what is the average for all of the assignment 1, 56, 88, 95, 76, 99. Assignment 2, 79, 62, 88, 88, 92. Assignment 3, 90, 68, 92, 85, 95, and so forth. So this is a little bit different. It kind of goes vertical. And if you look at this carefully, I can actually turn this into a list, like a nested list. And which is what I'm doing here. I want to get the list of all the student value. The value would be all of the grade, and I turned it into a list. So this would be a nested list. And in this nested list, I will go into each of the grade. And I will go through each of the student grade. So this will go from like a student list, a student grade list sub 0. This kind of going through how many tests are there, how many columns are there. Why? Because I want to move the column last, but I want to move the row first. So for column in range, student grades list, I want to find out for each student, for each assignment, what is the total. Maybe instead of a column, I should do a row here, because this is like a row 1, row 2. I should put a row here. Maybe that would be better. The row in the student list, and maybe I would print out what this look like here. So you know, this is a nested list, and how I want to traverse that. And finally, I apply the curve to each student total score, so that the best student 100%. So I had the student average, if you recall earlier. I just get all the student name and the grade. So before applying, I just showed before applying, and I will apply the highest. I saved the highest earlier, the highest average. So what I'm doing is the student average sub student divided by the highest percentage, times 100. So the person with the highest percentage, he will get 100%. The person with less than highest percentage, I divide by highest. So I basically move the scale. Instead of 100% scale, it could be like 80% or 90%. It just kind of like proportionally change. And let's see how this program runs here. Maybe I should move this over on the side. You can see better this way, and make it a little bit smaller for now. So student with a high average is Trisha, and her average is 94.8%. You can see Trisha had the most high score here. And I print out the list of the student grade. You can see the list of the student grade is a nested list. So what I'm doing here is I'm just iterate the list. So I want to get here that in a total student grade sub list sub row sub index, the rows, I just transfer the rows like this would be row 0, row 1, row 2, row 3, and row 4. Index is the first index, so kind of like I was doing like a 0 0 1 0 2 0 3 0 4 0 to add the total for that column, and then find the average. And that should be just a student list. Okay, let me run this again. I think I have a little. This should be, I divide by the total divided by length of the student list. The length tell me how many rows are there. The number of rows tell me how many students are there in this case. So this is the average for each of the assignment. And finally, I apply the curve. Before I apply the curve to NGU, NGU curve average is the NGU, I guess. Student NGU, the curve average. So before and the curve. So before NGU is, let me see, before applying the curve, student and the curve average. And so this is before he got 59.4 and after he got 62.7. Before knee screen have a 74.2, after he got 78.4, 78.3%. Allen 89 to 93. Chen, he got from 84 to 88.8. And Trisha, which got 94.8, and after the curve, she got 100%. You can take a look at this program. You can pause the video and see how I did for each student. And I will talk more about this when we meet in class.